Okay, and welcome to the problem section on sum and difference formulas, and we'll do a number of problems. Each one of them takes a little bit of time. The first one is find exact values for sine of 75 degrees. So we look at how can we split up sine of 75 degrees. Well, what we do know is we know the sine of 45 and the sine of 30 degrees, respectively, cosine of those. So we're going to split it up into 45 plus 30. So 45 plus 30 degrees. And now we're going to look at the identities. So for sine A plus B, we have sine A cosine B plus cosine A sine B. And that, of course, is where we're going to plug in the 45 degrees for the A, the 30 degrees for the B, okay, and now I need to go to the next line anyway. So sine of 45 degrees, of course, is the square root of 2 over 2. I don't bother with using the equation editor. We can do fractions like this. Times cosine of 30 degrees is square root of 3 over 2. Plus cosine of 45 degrees. Square root of 2 over 2 times sine of 30 degrees is 1/2. Okay, actually I wouldn't mind leaving the 1/2 like this. And then we have the square root of 6 in the front over 4. So square root of 6 over 4 plus square root of 2 over 4. Combine those two fractions. Easy since they have the same denominator, so it's going to be square root of 6 plus square root of 2 in parentheses over 4, and we're done. Okay, tangent of 75 degrees, because that will entail this complicated fraction down here. I use the equation editor. Tangent of 75 degrees is the same as tangent of 45 degrees plus 35 degrees. 30 degrees, of course. 30 degrees, okay, equals. Now comes this interesting this interesting equation, or fraction. So it's going to be tangent A. And then it says a plus in between here, right there it says a plus. So according to the identity, there's also a plus, tangent B. Then we're going to have 1 minus, and notice that in the identity, when we have a plus, that turns into a plus in the numerator, but into a net minus in the denominator. So it's going to be 1 minus tangent A, tangent B. And now I'm going to plug in these numbers. 45 degrees right there, 45 degrees right there. That's 30 degrees right there, and that is also 30 degrees right there. Okay. Now we'll go to the next line and now put in the exact values. I know that tangent of 45 degrees is 1. And there it is again, 1. Might as well put a times here. Tangent of 30 degrees is 1 over the square root of 3. Let's see if I have something convenient here. Not, well, maybe this one. So I have 1 divide by the square root of 3, and then here, if I'm able to grab this, I have the same. Here we go. And now I can look at if I can somewhat simplify that. Well, actually I can. I can just multiply every single term with square root of 3. So I'm going to do that. And I'll make it look a little bit nicer. This term times the square root of 3, of course that. This term times the square root of 3 gets rid, just this, the 1 survives. This one here, square root of 3. And here it's just going to be simply 1. And that's pretty much it. There's nothing else we can do. I'm actually going to write my results on the side here because I'm going to go soon to the graphing calculator. So on this one I came up with square root of 3 plus 1, square root of 3 minus 1, and in the previous one we had square root of 2 minus square root of 2 plus divide by 4. Okay, let's do this one here. Cosine of 7 pi over 12. 7 pi over 12, that's 105 degrees. How are we going to split that one up? Well, we have cosine of 60 degrees plus 45 degrees, right? Well, 60 degrees is pi over 3. Over 3. And then we have 45 degrees, pi over 4. Equals, so what are we going to do here, which identity, well this one here, cosine A plus B, which will become cosine A, cosine B, and then it says minus. So the plus turns into a minus. Sine A, sine B. And I'm going to go to the next line. Just want to double check here, pi over 3 plus pi over 4. If you add those up, you have 4 pi over 12 plus 3 pi over 12, which of course is the original 7 pi over 12. So let's plug in these numbers here. Pi over 3 right here. Pi over 3 and pi over 4. Wow, looks like we need a little bit more space. Oh, bummer. Yep, there you go, fortunately. Okay, let's see what we get. Cosine pi over 3, which is cosine of 60 degrees, which is 1/2. I do like to keep that actually. Times, let's see if I can grab that from somewhere. Cosine of pi over 4, which is square root of 2 over 2. There it is. Minus. By the way, when I just type this here, you know, whatever that is, I just type something on my keyboard here, and all that happens is that it extends that tiny negative to a nicer looking negative. That's the only reason why I do that. So I'm going to have sine pi over 3, which is the square root of 3 over 2. Times sine pi over 4, which is 45 degrees, square root of 2 over 2. Equals, well, it's going to be the square root of 2 over 4. Square root of 2 over 4 minus square root of 6 over 4. Can I steal that from somewhere? I guess up there. Square root of 6 over 4. And then, of course, combine the two. Again, I'm going to steal something here. And, well, actually, this one is actually convenient, more convenient. So we have your parentheses. There we go. I think I got it. Let's see. Now I'm going to jot this down here, and then we're going to go to the graphing calculator and we check these results. Okay. The first one was sine of 75 degrees. And that should be in the neighborhood of, between 0.866 and 1, so 0.9 maybe. That obviously tells us that we're not in degrees. So I have to go to mode and switch from radians to degrees. Okay, now let's do this again. There we go. That looks better. 0.96. Now we're going to see what we came up with, which was the square root of 6 plus the square root of 2, parentheses for the numerator, divide by 4. Same thing. So we did it correctly. I'm just going to do that a couple times more because I want to perhaps have a screenshot of that. There we go. Okay. Next example said tangent of 75 degrees. Should be larger than the square root of 3, right, which is 60 degrees, so larger than 1.7, 2 point something, 3 point something. Yeah, there you go, 3.73. And we came up with square root of 3 plus 1 divided by square root of 3 minus 1. Enter. Same thing, 3.73, so we did it correctly. Okay, now I just took a screenshot of that. Okay, next one says cosine of 7 pi over 12, and of course means that we have to switch to radians. Unlike what we did before with proving identities, well, we came up with sines and cosines on both sides, tangents and so on, and it doesn't matter if you're in radians or degrees, but here we come up at the end with a number as we took the cosine of that, so we have to make sure that we're in the correct radians or degrees. Okay, so that one here comes out to, let's see, where are we? Cosine of 105 degrees, a little bit less than 0. Indeed, minus 0.25. And we came up with the square root of 2 minus the square root of 6, parentheses, divide by 4. There we go, minus 0.25, same thing. Okay, let's go to the next example problem. Okay, here it says write as a single trig function. Sine 3x cosine 2x plus cosine 3x sine 2x. Well, it's the same as sine cosine plus cosine sine, so we come up with sine a, parentheses, sine a plus b, and I could almost do that on one line, equals sine 3x plus 2x which is the same as sine 5x, of course. Cosine cosine plus sine sine. I'll also make sure that it's 3x 2x, 3x 2x. So we have cosine cosine plus sine, which turns into cosine A minus B. So we have your cosine A minus B. And that equals, again, I guess I put this on one line here. So we have cosine of 3x minus 2x, and that of course comes out to simply cosine 1x. Whoops. Okay, the next problem says graph the following for from 0 to 2 pi. Graph for x equals 0 to x equals 2 pi. Okay, let's do it. What should we come up with? Well, when we do that, we have cosine, cosine, plus sine, sine. So, which is this one here, which will turn into a cosine with a minus in between. So cosine 2x, that's what it should be, with an amplitude of 3. So we should come up with cosine 3 cosine 2x. So let's do it on the graphing calculator. Okay, don't need this here. Go over here. 3 times parentheses. So I'm going to do the whole thing here. Cosine 7x times cosine 5x plus I just noticed that in Word I did make a tiny mistake. There was actually a 3 in front of the second one as well. Let me actually get rid of this one here. There we go. I forgot that to type in a 3 in Word. I will correct that one when we get back. Times cosine of 5x. Let's see. Cosine, cosine, sine, sine. Oh, there we go. There it is. That's a sine as well. Alright. Got it. Let's see what we come up with. Actually, we're just supposed to do that in from 0 to 2 pi. So I'll fix that in just a moment. It takes a long time to graph because there's so much information in the equation. So from 0 to 2 pi, and then maybe our y is going to be negative 5 to 5. Unfortunately, it's going to take just as much time. So we just wait for that. And as I said, when we combine this here, we should come up with a cosine 2x and an amplitude of 3. So I'll be graphing that as well once this one is finished. There you go. So 3 times cosine 2x. And of course, since it's supposed to be the same, I might as well make this in bold. This one goes faster because it only needs to calculate one cosine rather than 2 cosines and 2 sines. And as we can see, that is indeed is correct. Again, I'm going to make a screenshot for myself. And go back to Word. Okay, so here's what I had forgotten. There's a 3 in there as well. And I will paste this in later. Last problem, we're supposed to do the following. Let sine A equals 3/5 with A in quadrant 2. And sine B equals negative 5/13 with B in quadrant 3. Okay, and we're supposed to figure out what is sine A plus B cosine A plus B, and we're supposed to figure out in which quadrant A and B is terminating. So let's start out with sine A plus B. Let me get the identities again. Okay, here we go. Sine A plus B. Well, that's gonna be sine A cosine B plus cosine A sine B. Plug in the numbers. We already know that sine A is 3/5. Do we know cosine B? No, it's not given. But we have these nice Pythagorean triangles here where we have 3/5, so the missing side is a 4, and here we have 5/3, so the missing side is a 12. We should be familiar with that. You know, 5 squared plus 12 squared equals 13 squared. So we know that cosine on this one here is going to come out to 12/13. And we're in quadrant 3, so it would be a negative. So we have times negative 12/13. So that's actually multiplication right here. And I think I'll push this to the next line here. Oops, not an equal, but there's actually a plus. Cosine A, well, that means that cosine is 4/5, but we're also in quadrant 2. That means that the cosine is negative. Times sine B, where we already have it given as minus 5/13. So there we go. And we come up with negative 16/65. I did this here in my notes on the side. You may double check that. Maybe I do want to put parentheses around this one here. Yeah, so please double check that indeed this one is negative 16/65, rather complicated fraction. And I'm double checking my own results here with my notes, provided that my notes are correct. And we know that this one for sine to be negative is either in quadrant 3 or quadrant 4. Cosine A plus B. So we're going to come up with cosine A cosine B minus sine A sine B. So I don't want to retype everything, so I'm just going to steal this from somewhere else. Sine, and then we have negative right there. And I believe that is correct. Yep. So cosine A, where we did that earlier, is negative 4/5. Cosine B, we also did that earlier. It's negative 12/13. Then we have another minus. Whoops. There you go. Sine A was given as 3/5. And sine B was given as negative 5/13. And again, I'm double checking with my notes that I got it correct, and it sure looks like it, and I come up with, again, an unwieldy fraction of 63/65, which means that one for the cosine has to be in quadrant 1 or quadrant 4 in order to be positive. Again, you know, this is the cosine, and the cosine can only be positive in quadrant 1 or 4, while a moment ago the sine comes out to negative, and that can only be in quadrant 3 or 4. Looks like at the end we actually come up with this one here. We're going to be in quadrant 4. That's the only overlap we have. Okay. tangent a plus b, actually for that one I do need the equation editor, so I'm going to use that one. So tangent a plus b equals fraction. So tangent a plus tangent b divided by 1 minus tangent a times tangent b. Okay, let's see what happens. Equals. I guess I'll need a fraction bar. Okay, tangent A, for the angle A, given the 3, 4, 5 triangle, of course we're going to come up with 3/4. But we are in quadrant 2 for angle A, so it needs to be a negative for the tangent. And we have plus tangent B. We have, let's see, 5, 13, and 12, so 5 over 12. And we're in quadrant 3 for that tangent, so it's a positive. And we have 1 minus, same here. And I'll put this in parentheses. There we go. Times tangent B, well, there it is, 5/12. There we go. And now you do the whole fraction. I'm just double checking with my notes, and indeed that is correct. And when you do the whole rearranging of these fractions and multiply them out, you come up with negative 16. And I have a 63 here. Okay. Oh yeah, that would make sense. Which actually I could have seen already here at these here, you know, if I have negative 16 over 65 and 63 over 65, and I should come up with negative 16 over 63 for the tangent, which is what we did. And negative, which means that tangent here needs to be in quadrant 2 or quadrant 4, and we have complete overlap for all of these here only in quadrant 4. And with that, I conclude the problem section on the section sum and difference formulas.